Welcome to the debate. Today, we are turning our attention to the absolute heavyweights of the Royal Australian Navy, the Canberra-class landing helicopter docks, or LHDs. We are talking about HMS Canberra and HMS Adelaide. These are 27,000-ton amphibious assault ships, the largest vessels the Navy has ever operated. They are designed to be the Swiss Army knives of the fleet, capable of projecting force, launching helicopters, landing troops, and providing humanitarian aid anywhere in the Indo-Pacific. But right now, despite their massive strategic value, the data paints a very worrying picture. We are effectively operating what the experts are calling a one-ship force.
It is a confronting reality. The target availability for these ships is supposed to be 80%. That is the promise that was made to the government. But in practice, we are sitting stubbornly at, 55 to 60%. It is a genuine crisis of sustainment. And today, we are dissecting a very specific, high-level technical assessment by MBPD Consulting titled LHD Detailed Network Science-Based Technical Assessment. This document is a direct response to the Australian National Audit Office, the ANAO, report number 50 from 2024-25, which was, let's be honest, absolutely scathing about the state of these ships.
It was a brutal report. And the central question we are grappling with today is whether a radically different engineering philosophy can actually fix it. Can the application of network science, specifically something called scale-free network theory, solve the sustainment crisis? Can we fix these ships by simply being smarter with how we view the data? Or is this a theoretical solution that just ignores the hard realities of fixed budgets and statutory compliance? I'm here to argue that the MBPD proposal offers a scientifically proven, fiscally neutral path to restoring full operational capability. By treating the ship as a network and prioritizing hub maintenance, we can stop the cascading failures that are crippling the fleet.
And look, I see the elegance in the mathematics. I really do. It's a compelling intellectual exercise. But I'm here to argue that while the model is sound on paper, it ignores the fixed costs of maritime reality. You cannot algorithm your way out of a classification society survey, and you certainly can't simulate technicians that simply don't exist in the workforce. This proposal claims to be fiscally neutral, but I believe it trades mechanical failure for administrative grounding. You might get the engine running, but if the paperwork isn't signed, that ship stays at the wharf.
I want to start by framing the problem because the MBPD report does something very different from a standard engineering audit. Usually when a ship breaks, the Navy looks at a list of broken parts, a pump here, a valve there, a circuit board somewhere else. But this assessment looks at the LHD not as a list of parts, but as a scale-free network.
Which sounds impressive, but for the benefit of our listeners who aren't data scientists, let's strip the jargon. What does that actually mean in the context of a steel ship sitting in Sydney Harbor?
It's a crucial distinction. Think of a random network like a highway map of rural Australia. Most towns have roughly the same number of roads leading in and out. If you close one road or one town, traffic diverts. The system survives. It's robust. That is not how an LHD works. An LHD is structured more like the global airline network. You have hundreds of small airports, those are your minor systems, but you have a few massive hubs like Heathrow, Dubai, or Singapore.
And the logic follows that if Heathrow shuts down, it doesn't just affect London. It ruins flights in New York, Tokyo, and Sydney. The chaos spreads.
Massive network of over 150 subsystems connected by nearly 600 dependencies, but they are not created equal. The ship actually relies on just 12 to 15 critical hubs. We're talking about the diesel propulsion system, power generation, and the combat management system. These are the Heathrows of the ship.
Sure, but those are obviously the big-ticket items. Any chief engineer knows that if the engines stop or the power goes out, the ship is dead in the water. That's hardly a revelation.
The revelation isn't that they are important. The revelation is that our current maintenance strategy doesn't treat them that way. The report calls the current strategy spreading the peanut butter. We have a limited budget, and because we are trying to be, fair to every system, we are deferring maintenance evenly across the board. We are treating the Heathrow of the ship with the same level of urgency as a small regional airstrip. The analysis shows that a failure in one of these hubs doesn't just take that system offline. It triggers a cascading failure that wipes out 30 to 50% of the entire platform's availability.
I don't dispute the peanut butter problem. The ANO report was crystal clear that we are deferring 68 to 72% of maintenance annually. That is a staggering number. I mean, 2/3 of the work that needs to be done is being pushed to next year, every year. It's a rolling snowball of debt. But my argument is that this isn't a strategy choice. It's a poverty choice. We aren't spreading the peanut butter because we think it's smart. We're doing it because the jar is empty.
But if the jar is nearly empty, surely you have to be ruthless about where you put the knife. That is the core of the MBPD proposal. It suggests reallocating $36 million, about 20% of the sustainment budget, to aggressively maintain just those hubs. If you stop the hub from failing, you stop the cascade. You protect the ship's core function.
Aggressively maintain is a nice phrase, but let's look at the mechanics of that $36 million. The proposal claims to be fiscally neutral. That means they aren't asking the government for a new bucket of cash. They are taking it from elsewhere in the existing $180 million annual budget.
Which is the only realistic option in the current fiscal climate. We can't just print more money.
But here's the trap. The source material explicitly admits that mandatory statutory surveys, the ones required by Lloyd's Register to keep the ship legal, consume 8 to 12% of the budget. These are fixed costs. You cannot negotiate with Lloyd's Register. They are the maritime police of safety standards.
Well, you can negotiate the timing slightly, but not the requirement. I grant you that.
Precisely. These are rigid cycles. Annual inspections, intermediate surveys, the big 5-year dry dockings. So if you rob the budget to pay for this hub prioritization, where does the money come from? You risk failing those statutory surveys. A ship with perfect diesel engines is still useless if its safety certificates have expired. It gets detained. It can't deploy. It becomes a very expensive floating hotel.
I think you're conflating administrative risk with operational capability. The report acknowledges the class society issue, but it frames it as a choice. Do you want a ship that is legally compliant but technically broken, a paper tiger, or a ship that actually works?
I want a ship that is allowed to leave the wharf. We're talking about the license to operate. And then there is the workforce gap, which acts as a multiplier on all these costs. The MVPD plan assumes organic Navy labor rates at about $90 an hour. That's the internal cost of a sailor turning a wrench. But the ANO found a shortfall of 40 to 60 technicians. That means the Navy doesn't have the bodies, so you're forced to use contractors.
Who are significantly more expensive, yes.
Double or triple. You're looking at $150 to $200 an hour for commercial contractors. So the math on this fiscal neutrality starts to fall apart immediately. You can't efficiency your way out of a labor shortage. If you need 100 people to fix the hubs and you only have 60, you are paying a premium that just blows the budget out of the water.
I want to drill down into the labor issue later, because I think there's a nuance there regarding retention. But first, we need to cement the diagnosis. You mentioned the math, but the network science reveals something terrifying about why these ships are failing. The ANO data shows that critical defects make up only 6.7% of the total. That's 15 out of 223 defects. A tiny fraction.
But a persistent one.
A devastating one. These 15 defects drive the vast majority of the downtime. Let's look at the specific examples cited in the report. The Tonga mission in 2022 and the Vanuatu mission in 2023. These were humanitarian assistance and disaster relief missions, HADR. This is exactly what the LHD is built for. And they suffered total power blackouts.
Which is unacceptable, obviously. The ship goes dark, the air conditioning stops, the food in the freezer spoils. It's a disaster.
But why did they happen? It wasn't random bad luck. It was Barabasi Albert dynamics. Here is the chain reaction the report describes. A diesel engine fails because of deferred maintenance, perhaps a dirty injector or a cooling pump. That forces the ship to rely on the electric azimuth thruster for propulsion.
Which, for those who don't know, is a massive electric motor hanging off the back of the ship in a pod. It draws a huge amount of current.
Exactly. It overloads power bus B. Now, because power bus B is sagging, the voltage drops. Who suffers? The combat management system, the C4SIR. It gets voltage starved and crashes. So you start with a dirty fuel injector in the basement. and you end up with a command center that can't see, communicate, or fight. It's a domino effect.
Look, I don't dispute the domino effect. The engineering logic holds up. But calling it Barabasi-Albert dynamics is just a fancy way of saying we ran the equipment into the ground. This is a symptom of chronic underfunding. The ANAL report states that defense estimates for sustainment were 20 to 25% too low from the very beginning of the program. We bought a Ferrari and budgeted for the maintenance of a Toyota Camry.
But money isn't the only variable here. If you have a Ferrari, you don't save money by skipping the oil changes. You save money by maybe not detailing the leather seats every week. You protect the engine.
But in this analogy, the leather seats are things like the sewage system and the fresh water makers. And that brings me to the peripheral node risk.
Right. The reallocation strategy. To fund the $36 million for the hubs, the advocate position, and the MBPD report suggests taking $144 million away from peripheral systems.
Think about what that actually means. Peripheral systems are HVAC, sewage treatment, fresh water, galley equipment, laundry.
Less critical for a warship's fight capability, surely. If the radar works and the guns work, the ship can fight.
A warship is also a home for 680 people. If you strip the budget for the minor issues, eventually they accumulate. You might have a ship with a working radar and a perfect diesel engine, but if the toilets don't flush, the air conditioning is broken in the tropics, and the galley can't serve hot food, you have a crew that is miserable, fatigued, and potentially sick.
But the ship can sail. That is the priority.
Can it? I mean, if you have a dysentery outbreak because the sewage system failed, or if the crew is heat stressed because the HVAC is down, that ship is effectively inoperable. You cannot fight a ship with a sick crew. The peripheral node risk isn't just about comfort, it's about endurance. You're robbing Peter to pay Paul, but Peter is the guy who makes sure the crew has water to drink.
It's a grim calculus, I admit. But the alternative is what we have now. A ship that is comfortable but immobile. The MBPD proposal argues for a triage approach. We have 223 urgent defects. 60 of them are critical hubs. The plan is to focus on those 60 immediately. The model predicts that by pushing hub maintenance completion from its current dismal 30% up to 85%, we get a 3 to 3.5 times improvement in resilience.
Predicted being the operative word. Models are great, but they rarely account for supply chain friction or the fact that parts go obsolete.
It is based on 10 years of operational data. The logic is that preventing the cascade is worth the risk elsewhere. If you stop the diesel failure, you save the combat management system. You restore redundancy. Right now, the LHD has backup systems. It has backup generators, backup pumps, but they're broken too. So when the primary fails, the backup isn't there and the system collapses. Restoring the hubs restores the redundancy.
But let's talk about the time it takes to fix things. The ANO report highlights a terrifying statistic: resolution timeline degradation. Major repairs are now taking 1,350 days. That is nearly 4 years. That's up 40% from the baseline.
Which is exactly why we need to change the process. The current system is paralyzed.
But why are they taking so long? The audit breaks it down. 30% of the delay is supply chain, waiting for parts. 20% is engineering authorization, waiting for a signature. Just prioritizing money doesn't make a spare part appear from a factory in Europe any faster. It doesn't make the engineering drawing get signed off faster if there's a bottleneck in the design office.
I disagree. If you prioritize the hubs, you focus your supply chain efforts there. You expedite the parts for the diesel engines, not the parts for the laundry machine. You tell the design office, drop the paperwork for the galley refit. We need the signature for the propulsion control unit right now. Network science gives you the target list for that expediting.
That assumes you have the people to do the work. And we loop back to the workforce. The plan relies on efficiency gains. It says, we will be more efficient with our labor. But the ANAO found that critical shortfall of 40 to 60 organic technicians. You can't efficiency your way out of a 20% staff shortage. You need bodies on the deck turning wrenches.
The counter-argument, and it's a strong one, is that by fixing the root causes, the hubs, you reduce the overall workload over time.
Fewer cascades mean fewer emergency repairs. You move from corrective maintenance, fixing things that have exploded, to preventive maintenance. And this touches on retention. Sailors don't want to serve on broken ships. It is demoralizing to be on a platform that can't do its job. If you fix the ship, you stop the sailors from leaving.
I agree that morale is tied to capability, but the transition period is the valley of death. You have a backlog of 223 defects right now. You have to clear those while simultaneously pivoting to this new preventive model, all while being short-staffed and underfunded. How do you cross that valley without breaking the existing crew?
It is a valley of death. But look at the alternative. The baseline scenario, doing what we are doing now, guarantees a $2.5 billion cost over the next 10 years. And for that money, we only get 55% availability. We are paying premium prices for a part-time Navy. We are essentially burning money to keep the ships alongside the wharf.
The cost of the current path is certainly ruinous. I'm not defending the status quo. It's unsustainable.
The network science tells us why we are failing. We are treating a scale-free network as if it were a random collection of parts. We are ignoring the topology of the ship. The hub prioritization is the only scientific path to getting back to a 3-ship force. If we don't stop the cascades, we never catch up. We are just treading water while the machinery rots.
I don't disagree that the strategy is smarter. My concern is that it is a strategy for a Navy that we don't have the budget for. The analysis is brilliant. It really is. It exposes the mechanism of failure perfectly. But it also exposes a fatal flaw in the program itself. The Navy cannot afford the ship it bought.
That's a stark way to put it.
It's the truth. Without an additional funding injection, and I'm looking at that $200 million for class society compliance specifically, this proposal is just reshuffling the deck chairs. You might fix the engines, but if you lose your Lloyd certification or if you burn out your remaining crew because the living quarters are falling apart, you still don't have an operational capability. The report tries to find a solution inside the current budget envelope, and I just don't think the numbers fit.
But if you had to choose, and this is the choice defense faces right now, between a compliant ship that can't move because its power grid collapsed and a capable ship that requires a paperwork waiver, surely the choice is clear.
In war, maybe. In peace, regulations are written in stone. And let's not forget, the ANAO pointed out that the $300 million emergency injection in 2024 only addressed symptoms. We are addicted to emergency funding because we won't fund the baseline correctly. This proposal tries to fix that without asking for more money. And I just don't think the math works when you factor in the humans and the lawyers.
And yet, it offers a glimmer of hope, a way to break the cycle of deferral. The proposal also suggests a new governance structure, a steering committee to ensure accountability. This moves away from those failed contracting models we've seen in the past, like the asset class prime. It puts the Navy and the sustainment group in a room with a mandate to fix the hubs.
The of money was too small.
We've covered a lot of ground today. The LHDs are clearly a scale-free network, and the evidence suggests they must be treated as such. The hub prioritization model offers a fascinating data-driven way to look at maintenance. It suggests that by saving the hubs, we save the ship. It's a pivot from fix everything to fix what matters.
And I maintain that while the science is sound, the logistics and economics are precarious. Unless the government opens the checkbook to cover the structural deficit, especially regarding compliance and workforce, this scientific solution might just be a sophisticated way of describing why we are stuck. It's a map, but we still need to buy the fuel to drive the car.
It's a debate that goes to the heart of how we manage complex defense assets. Should we apply this hub model to other platforms? Can we afford not to? Or is the root cause always just money?
That is the question. And for the sailors on HMAS Canberra and Adelaide, the answer can't come soon enough.
Thanks for listening to The Debate.